An ion is a charged atom. Here we see two of them, a calcium and a strontium ion. They are superb, controllable quantum systems, and we'll see we can store information into either one. Suppose our strontium is initially in state 0. We can apply a pulse of energy to switch it to state 1. Later, for readout, we can use a laser that would have no effect on state 0. But our ion in state 1 will absorb energy and then emit it back as a photon, a particle of light which we can detect. Let's zoom out. We see gold strips below. These produce electric fields holding our ions still without physically touching them. And again we see a laser causing an ion to become excited and emit its photon. Zooming out further, we see the gold strips are part of a small chip called an ion trap. And then we see surrounding electrical and cooling systems. A final zoom reveals the entire system is encased in a vacuum chamber which protects it from the atmosphere. Surrounding the vacuum chamber are laser systems, field coils, and crucially a photonic link system to capture the photons into an optical fiber. This complete module is a small quantum processor, but now consider two linked modules. When photons meet at the entangler unit in the middle, the ions that created those photons become quantum entangled. And so the two modules combine as a single quantum machine. Extending this idea, we can have an entire array of modules. We can switch connections so that a module links either to a nearby neighbor or to another far away. In this way, we can have a highly connected and scalable quantum brain.
Imagine sitting in a pristine, ultra-modern lab surrounded by gleaming equipment and an eerie silence. Before you stands a quantum computer, a device that doesn't look anything like the typical desktops you're used to. Instead, it resembles a futuristic chandelier with intricate layers of wires, superconducting loops, and delicate cooling systems housed in a vacuum-sealed chamber. It feels more like you're in a science fiction movie than a tech lab. You're guided through the process by a team of quantum scientists. They explain that this computer operates on quantum bits, or qubits, which can exist in multiple states simultaneously thanks to the principles of superposition. Unlike classical bits which are strictly 0 or 1, qubits open a whole new dimension of possibilities, allowing quantum computers to perform calculations that are unfathomably complex for traditional computers. As you prepare to input a task, you realize that programming a quantum computer is nothing like writing code in Python or Java. It involves abstract concepts like quantum gates and entanglement, requiring a shift in thinking. The scientists load your problem, optimizing a complex supply chain or modeling molecular interactions, into the quantum algorithm. The room's environment is strictly controlled. The quantum processor operates at temperatures colder than outer space, shielded from vibrations and electromagnetic interference. It's humbling to think how fragile this cutting-edge technology is, yet how powerful its potential. Moments later, the computer performs a computation. It's not a dramatic display of numbers whirring across screens like in movies. Instead, the results are carefully interpreted by algorithms that translate quantum outcomes into meaningful data. The calculation that might take years for a classical supercomputer is completed in seconds. You can almost feel the weight of the quantum leap, pun intended, in technology as the scientists explain the outcome. Leaving the lab, you're struck by the sense that this is just the beginning. Quantum computers are still in their infancy, like the early days of classical computing in the 1940s. But the possibilities, solving problems in cryptography, artificial intelligence, and materials science are vast. It's not just an experience of a new technology, but a glimpse into the future of humanity's computational abilities. So, what do you think? Are you ready to dive into the quantum realm? Thanks for watching. If you enjoyed this video, hit that like button and subscribe for more tech explorations. See you next time.